Today we're going to go ahead and talk about machine learning. And to implement machine learning models, we would be using Microsoft Azure. Before we do get into the details of these topics, let's take a look at the agenda of today's session first. So first and foremost, I would be introducing you to machine learning. Now, it being a very vast topic, we would be first taking a look at some of its fundamentals, and then we would be switching to Microsoft Azure, and we would be seeing how machine learning can be implemented by using Microsoft Azure. Finally, I would finish things off with a demo part where I would be talking about Azure ML Studio that lets us carry out machine learning processes. I hope this agenda is clear to you guys. So let's move further and get started with the first topic of discussion, that is, what is machine learning? Well, if you go by the definition, it is nothing but the process where you teach a machine to take in some data, analyze it or understand it, and based on that data, give in some valuable outputs. Now, this is a very generic definition, but to give you more simpler an example, I would say that it is something similar to how we human beings learn. I mean, when we are born, we have no idea about anything that happens around us, right? I mean, we do not know what shapes are, what colors are. But as time progresses and as we hear people talk, we see stuff happening. When we learn to write, we actually go ahead and understand these things, as in what shapes are, what colors are, what people are, and all those things. So a machine learning process is very similar to this. I mean, what happens here as well is you provide in some valuable data to your machine, and you train your machine with that data again and again, or with new data as well. Now your machine takes in this data and it builds in a pattern or an algorithm using which, if similar data is given to that machine, it would be in a situation where it can probably classify this data or predict something or collaborate this data into something else. So this whole process is machine learning. Now, as I've already mentioned, machine learning is a very vast domain. As we move further, we would be discussing these terminologies as in classification and all those things. But for now, in simple words, it is nothing but the process where you give in some kind of data to your machine. It understands that data, and based on that data, it helps you take better decisions. So let's move further and try to explore or understand some other topics as well. So what do we have next? Well, let's take a look at some of its fundamentals. If you talk about machine learning, we need to consider two important points, that is supervised learning and unsupervised learning. Now, these are two important classifications if you talk about machine learning. We also have something called as iterative learning as well, but we won't be getting into the details of that. As far as this session goes, we would be sticking to supervised learning and unsupervised learning. So when you talk about supervised learning, it is nothing but a process where you actually go ahead and teach a machine to predict something based on the information that you already have, or you at least know the target variable to be more precise. Now, what do I mean by this? Well, in this case, you actually know what your final outcome should be like, or you at least have the parameters that help you govern your final output. When you talk about unsupervised learning, that is something you do not know. Let's stick to supervised learning for now and consider this example. Suppose you have some data set where you have information, as in you have some data where you know that certain values or certain records are for ducks and certain values are not for ducks. So what you do is you pass in this data to one of your machine learning algorithms, or you build a model around this data, and when you pass in a new value to this so-called model, that model should be able to predict whether that value is for duck or it is not for duck. Now in this case, this value is not meant for ducks, so the answer should be not duck, because we can clearly see from the image it is a piglet, so that cannot be a duck. Now this is a very simple example of supervised learning. What we are doing here is we know that what kind of output are we expecting. We are expecting an output where we know either it's duck or it's not duck. So our target variable is fixed. I mean, we know what we are researching for or what we are analyzing the data for. Now these kind of algorithms are called as supervised learning algorithms, or this process is called as supervised learning. So yeah, this is a part of machine learning. Now important point to note here is your data is labeled. Now that is what I mean by the target variable, which I just talked about. You know what your final value is, and that is why your data is labeled. You know what you're trying to predict or what your final outcome is. So this is a very important point to consider. Your data here is labeled and you know your final goal, as in what are you trying to achieve. If you talk about the next method or next approach, that is unsupervised learning, here you do not have labeled data. That means you do not have a final target variable. In this case, your final target variable or attribute, it can be random or it can vary, or once your model ends, you would be reaching there, but that is something which is not consistent. That can vary depending upon the needs that you have. Let's take an example to understand this a little more. Now, as you can see, we have some pictures, or on the screen, you can see certain species of animals and birds. So if I want an algorithm to classify these pictures or these records into their clusters, this would be more or less an unsupervised algorithm. Let's take a look at it first. So as you can see, we can pass in this data to our unsupervised learning model or build a model around this data. Once that is done, it should be able to classify my data into different clusters. Now, as you can take a look at the clusters, you can see that it has classified my data into ducks and something that is not ducks. Now, you might wonder as in, okay, this is similar to what happened in supervised learning, right? But in supervised learning, that is what my target was. I knew that I wanted to predict whether it's a duck or not. In this case, that might not be the case because, say, for example, I have this data where I have animals and birds, and I do not know what animals and what birds are there. There might not be ducks in it, right? There might be just mice, there might be just rabbits and all these things. Or you might want some extra clusters as well. For example, I want to segregate birds, I want to segregate animals. Now, in this case, my final output is varying. It can differ, right? I mean, I might expect different outputs out of it. So since I do not know what my final output is, I do not know what clusters are getting formed here. So that is why this kind of algorithm is called as unsupervised learning, where this is more or less similar to your black box testing kind of a process where you do not know what your final output is, but you do run in your algorithm and then you expect a more organized output that would lead you to better decision making. An important point to note here is the data here is unlabeled. I hope these algorithms were clear to you guys. If you do have any doubts, do let me know about those as well. We would be getting back to you on those doubts as well. But in simple words, this is what supervised and unsupervised learning is. Now let's move further and try to understand some other things as well. If you talk about different machine learning algorithms, you have these classifications here. First, we have supervised learning, and in that, we have something called as regression and classification. Now, these are two of the most popular algorithms or two popular branches of machine learning algorithms. If you talk about regression, it is a process where you try to find out relationship between two or more variables. Suppose I have to detect, as in, if I smoke, would I be having cancer, or what is the probability of me having a cancer? Now, this is an example of regression because I'm trying to compare cancer with smoking, right? So I'm trying to find out a relationship between these two. So these kind of algorithms are called as your regression algorithms. And then you have something called as classification. Now in classification, you basically classify your data into groups. Consider this example. I need to classify my particular data set or information into different segregations or into different parts like male population, female population, and all those kind of stuff. So these kind of algorithms are called as classification algorithms. And if you talk about regression and classification, you have quite a few advanced algorithms as well. Say, for example, you have random boost, XGBoost, and these kind of algorithms, or not random boost, sorry, random forests. So you have these kind of algorithms, which are advanced level algorithms. Now, we won't be getting into the details of those algorithms, but those are important as well. So once you are thorough with what regression is, what classification is, I would suggest that you do go ahead and explore those algorithms as well. Moving further and talking about unsupervised learning, we have algorithms like clustering. The example which I gave you in the unsupervised learning slide was of clustering. So that is one method or one type of algorithm that unsupervised learning supports. Then you have something called as association. Now we all go to supermarkets, right? We buy stuff. Probably we go to buy some breakfast stuff. In that case, you would be buying breads, butter, maybe milk, right? So what shopkeepers do is, or what supermarkets do is, they normally place in products that people might buy in bunches or in groups. And this kind of process is called as collaborative filtering or implementing association laws rather. So what these association algorithms do is they help you predict, as in what is the probability of people buying certain products combined with other products, because it is understandable for people who are buying breakfast stuff, there is more probability that if you buy milk, you would be buying bread with it as well. So yes, this is something that falls under association and association laws, but that is a topic for some other time. I just wanted you to give you an introduction of what supervised learning is and what unsupervised learning is. I believe the idea is clear now. So let's move further and talk about something else. Yeah, so now we've talked about what machine learning is and what different kind of machine learning algorithms that are there. Now I would like to brief you through the process of how machine learning works actually. And this is pretty much common for most of the algorithms that you're going to implement. First and foremost, you would be needing data. Now I've already talked about the point that data is centric to machine learning. If you do not have data, you cannot make any predictions. And more the data, the better it is for you. So the first part is having data. And once you have the data, the next point you need to confirm or make sure is the data is appropriate for machine learning. And this is where pre-processing steps in. What pre-processing does is it helps you process the data that you have and prepare it for machine learning. I mean, your data might not always be clean. There might be some missing values, some repetitive values, which you do not want in your data when it is getting processed, right? So in this case, we filter out this data, we clean it, we fill in certain values, we predict certain values, and we put in those values there. And once this data is up and ready for working, then we pass it on further, and then we provide a particular machine learning algorithm to it. Now, this again is a trial and error kind of method where it seems simple at times because we've discussed all those machine learning algorithms, right? So to naked eye or to naked mind, basically, we might think in this direction where we would think that, okay, this is the kind of problem I'm dealing with, so this is the algorithm I might use. But that is not the case. At times, the data is misleading. We are not sure what kind of algorithm I want to use, what kind of data I want to pass, and how much data I want to pass. In that case, what we do is we first allot a particular algorithm, use it, implement it, then we test the values, then we try out some other algorithms as well, and then we come to a conclusion as in, okay, this is the best algorithm, and using which I've generated a model which is best to meet my needs. And while doing that, there are quite a few processes that happen, processes like training, testing, validating, where you pass in certain amount of data, you build the model, you train the model, and then again you pass or keep some data behind, which you later pass to test these models, as in, are they working properly or not? So this is an iterative process, and this might take in more than one iterations to actually go ahead and jot down or settle down onto a particular point. So once your algorithm is selected, once your machine learning model is built, you can actually go ahead and deploy this model into your environment or real-time working, where it would be able to predict the real-time data or the data you provide your so-called algorithm, right? So this is how the whole process of machine learning works. Now, the processes which I talked about, pre-processing, then implementing various algorithms, training, testing your data. Now, this again, they look simple, or when you listen to them, they seem pretty easy, as in training the data and all those things. But once you start implementing these things, it is fairly difficult. Ask any data scientist and that person would tell you that pre-processing is something that is very difficult to deal with, and mostly 60 to 70% of the work is done in these phases only. So what if we had something that could actually help us here? Wouldn't that be easy? I mean, if we could just speed up this process of pre-processing, algorithm selection, training and testing data, instead of doing these manually, can we do all these things automatically? The answer is yes. Now, this is where your Azure machine learning steps in. What Azure machine learning does is it helps you carry out the whole process. But as you can see, we have something called as ML Studio, and it focuses on your pre-processing, application of algorithms, and deployment processes. So bulk of the task which can be repetitive or which can require you to put in more efforts to implement manually, it actually helps you automate or speed up that process. So that is what ML Studio is basically. It is a studio or a service in a very popular cloud service provider, that is Microsoft Azure, which lets you implement various machine learning algorithms, and it carries out the bulk of tasks or the bulk processes which you would otherwise not want to do. Now, this is not something that actually is used to replace data scientists. You cannot do that. So no offense to any data scientist who is listening to this video or going through this video. It is more or less complementary to data scientists. You would be needing statistical knowledge, and hence we talked about machine learning a little, because even if you build models using Azure or any platform, you would be required to have proper statistical acumen or knowledge about data science, something that would help you understand the output of the models that you've built. So yes, some statistical knowledge would always help, and you cannot replace that. But definitely, if you are working on machine learning and you need to speed up this process or make it more efficient, then Microsoft Azure and ML Studio in particular is a very important resource for you to have. So what I'm going to do now is I'm going to switch into the demo part, and we would be building a model so that we can discuss some of this stuff that I've already talked about. And we also get to see how Microsoft Azure works in real time, right? So let me just switch to the Azure portal or console that we have at our disposal. So guys, what I've done is I've gone ahead and I've switched into my Microsoft Azure portal. For people who are completely new to Microsoft Azure, you can actually avail certain services that Microsoft Azure offers you for free for 1 month. Now, during this period, you can avail certain credit for US citizens or people who have an account in US region. They can actually avail up to $200 of usage where you can use certain services. Now, these services are chargeable. That is why the free credit that is made available to you, so which I believe is more than enough for 1 month's practice. So if you're somebody who's new to these platforms, I would suggest that you go through or sign up for Microsoft Azure and you can avail those services. Now, since I am from India, we have Indian rupees as our currency, and for our usage we are given somewhere around 13,300 INR or Indian rupees which is a very big amount if you talk about using a service for a month's time. So it actually serves my purpose. I have been using it for a long time. That is this particular account. I've had a couple of accounts, but this one is something I created some 15 days back. And as you can see, I still have like 12,400 something something, which I can use. And we would be not needing this much today, somewhere maybe 10-20 rupees to the max. So yes, you can go ahead and create this account. Once you do have this account, then you'd be having access to all the services that Microsoft Azure has to offer to you. You can go ahead and create all the resources you can have or utilize its compute services, storage services, database services, and all the services that it has to provide to you. But since we are talking about machine learning, we would be sticking to those applications as well. So in order to use your Azure machine learning, you need to create a workspace where you can actually go ahead and put in all your data. And once you create your workspace, you actually need to go ahead and sign into the Microsoft Azure ML Studio, which is an interface or IDE where you can actually go ahead and create all those models. So in order to go ahead and create a workspace, you just need to come here and type machine learning, and you might be having that thing in the suggestion. It was already typed, I believe, machine learning. And you have this place where it says machine learning studio workspace or service workspace. You can click on these. The studio workspace is something I've clicked on, and you need to put in some details, as in what is the name of your workspace, what subscription are you using, resource group. You can use the one if you already have one. If not, you can create one, just given some name. Now resource group is something that holds in details about your resources that you're using, and then what kind of storage account you are using. You can create a storage account as well. It's not a big deal. It is nothing but think of it as a storage place where you can store in your data. That's it. So you do go ahead and put in these details, and then you say create. Before that, you have to put in what pricing tier are you using, and you'd be entering the region where you want your workspace to reside. Now what cloud does is it stores your data in particular locations on the globe, right? So you can choose the location that is closer to you or closer to your business depending upon your needs. For now, I'm gonna stick to the basic one that is here because we are just creating a simple demo. In fact, I'm not gonna go ahead and create a workspace because I already have my own workspace. But you, I would suggest that you put in these details and create one. Once this workspace is created, you can actually just open it, and at the bottom you would be seeing an option called as machine learning studio. Else what you can do is you can type in this URL, and you would be redirected to this page where you have to sign in with your Microsoft Azure portal account. And once you do that, you would be redirected to the ML Studio that I'm talking about. So the workspace would be created. Once the workspace is there, you log into your Azure ML Studio, and once you do that, this is what you'd be having at your disposal. Now these are some of the experiments that I might have worked out or worked on in last week or so. Some of them are finished, some are still in drafts. So you can actually go ahead and create these workflows or these kind of workflows. Now you have so many options here. What are the projects that you create? Experiments, which we just saw, different web services that are made available to you. You can actually go ahead and create web services as well. You have your notebooks. Now you might not always go ahead and start from the scratch, right? You might have your code written in maybe R or some other language like Python. So you want to import that code, you can do that as well, or you can use the existing notebooks which Microsoft Azure has offered to you, where you have ready to use codes or ready to use models as well. And then we have data sets. Now again, you can import your data sets that you have. There was one financial sample data set which I imported recently. You can actually go ahead and use sample data sets as well. Now you can see there are quite a few data sets that are made available here which you can use and implement your own algorithms or implement the algorithms that Microsoft Azure has to offer to you, right? So you can do that as well. So it pretty much depends upon what do you want to do and what kind of processing do you want to do. As you can see, if you come here, you have some, this is somewhere you can see your trained models as well, as in the work you've done or some models that you've implemented. So you can have that here. In this case, we are going to go ahead and implement one of the algorithms or algorithms that are implemented by Microsoft Azure. So if I come here to experiments and I go to samples, you can see that we have so many implementations. So we would be taking a look at one of these, and then we would be implementing that on our own. Do not worry, we won't be copying it right away. So we have quite a few options here, as you can see. Okay, let's just go ahead and do one thing. Let's build our own model here. So for that, we need to go to experiments, or rather we can come down here and say new, and I say add a blank experiment. Let's just go ahead and try to build a recommender system or something like that. So to do that, let's call it say my recommender. There you go, and save it. Okay, there are no modules, so you cannot save it. So first, let's get started. Now, in order to create a recommender, for people who do not know what a recommender is, it is nothing but you pass in certain data and it might suggest, or the model might suggest you as in what you might like or what you might want to do. Say, for example, when you shop on Amazon or any other website that is there, you normally have some suggestions, right? I mean, you may like this, you may like that. Same as with YouTube, you go through certain videos and it gives you suggestions as in you preferably might like these videos as well. So that is a recommender system. So let's go ahead and create one recommender system. Let's create one for movies. So let's just go ahead and practice or play with the data that we have. For that, we would be needing a data set first, right? Now, if you talk about ML Studio, it is very simple. You just drag and drop stuff, just like creating workflows. It is as simple as that. Now, in order to use a particular data set, we have these saved data sets here. Samples. Let's make a recommender systems for movies maybe. Yep. So movies. Do I have something in movie? Yeah, there you go. Movie ratings. So we would be using this data set. Now, once you put in this data set, it is available. You can just go ahead and take a look at it. So let's just visualize this data. And as you can see, the information is here. It has certain values like user ID, movie ID, ratings, and timestamp. Timestamp is something that people do not use frequently, but yeah, these are things that are important to us. We have factors like your ID, that is your movie ID, user ID, and rating. It's somewhere around up to 10. So I believe it has started from 0 or 1 maybe. So we have ratings from 1 to 10, which we would be using. So this is the data that we've just visualized, but at times this data is not as simple and as managed. It might have some missing values and you might be required to play with it or make some changes to it. You can actually go ahead and put in some factors here as well. Now here you have so many options that are made available to you, right? So you can actually go ahead and process your data a little, manipulate your data a little, like you can take a look at statistical analysis and all those things. But this being a clean data, we do not need to do that. So we're just going to stick to the recommender system part here. So we have the data set now. I need to select the columns that I want to use. So I'm going to project certain columns out of it. So for that, we have a module here called as project columns. Okay, I don't see it here. I believe they've changed the name. Select columns to, okay, so this is the one. They've changed the name. It's called as select columns in dataset. So we drag it and place it here. And we hold on to the circle that is there on the previous module or the tab we had, and we pull it down so we can connect these two. Now they are connected, and but since I've connected them, there's an error here. It says value required. Now I need to pass in some values as in what are the columns I need to focus on, right? So I would be clicking on this icon here or tab which says launch column selector, and it gives me options. So I'm going to put in certain rules. Now what are the columns that I want? First I would say that get in all columns and just exclude the ones that I don't want. So what are the columns that I do not want? Timestamp was something that won't be very handy, so I'm going to remove that. So I would be excluding that and I would be saying okay. Once you do that, the error is gone. So we have the data set, we've selected the columns. Now next phase is I need to go ahead and pre-process the data, but data is already pre-processed, so I don't need to do that either. So in this case, I would be going ahead and splitting my data into two parts, my training data and my testing data. Training data is something that we would be passing on to the model, and we would be training a model based on the data. And test data is something that we would be holding back, and then we would be using that testing data to test our models or to predict the outcome or to see whether the model is working fine or not. So to do that, we need to split our data. So come here. This process is easy. Just go ahead and type in the words that you need to do and it gives you modules to do that. So split data, I just pass in the data. So I've gone ahead and I've created or I've pulled this split data module or tab into my workflow. So yes, the data would be split and it would be split in this fraction 0.5. That is, we would be using 0.5% data to test. That is half of the data to test and half of the data to train our models. So there you go. I won't be tinkering with these factors. Those are good enough for me. So let's just move further. Now there's an option here where you can zoom in or zoom out your model to fit in the screen. So the data is split now. Next job is to train your data. So train your recommender system. Do we have option to, yeah, train matchbox recommender. So we select this and pull it here. Now what we do is we pass in one of these branches here, first one, and the split data is passed on to this training module or tab. Now I'm not too good with the nomenclature, that is why this confusion. Let's call it tab. So yes, so I've pulled in this data into the tab. So this is something that would get trained here. and I need to score it as well. So once I come here, I select this first, and it shows me the details as in, okay, how many traits of the data that I have that I want to use to build this recommender system. Let's just say 10. Okay, 10 is fine. I don't see too many problems with it. Maybe let's do it 20. Number of recommendations I want. Okay, no, this can also stay to 5, no problem. Training batches, 4 is fine. So we just move further, and next what we do is we just go ahead and score the data that we have. So I say score, and I pick in this thing. So again, to this I would be passing in my training data here, and I would also be passing in my split data, that is the testing data. There you go. So the data that has been trained, that would come here, and also the testing data would be here. So I have this score where I need to give in the details as in what are the predictions that I'm looking for. Now I basically want prediction where I would be wanting related items, right? If I watch this movie, what kind of movie I need to watch, right? So this is what I would be entering here. So once I enter related items, it says what are the maximum number of related items to find from an item that you have. Let's say I want just one item. There you go. And so it would give me one related item to the movie. So if I pass in a particular movie to this recommender, it should suggest one movie that I might like watching. So that is what I'm talking about here. So one related movie, you can have more than one as well. So that is up to you. So we've done this. Now next is I built a model, or I've actually gone ahead and put in a tab for training and scoring. Next, I need to evaluate this data, right? So I say evaluate or test rather. So it says evaluate your recommender. You get in here, and this time you take in this value that is your score and you put it here in this column. We passed in one of these threads here. Next is we take in the split data and we enter it here. There you go. This is fine. I would be saving it here just to be safe. Once you save this data. Okay guys, so the connections that we pass in, these are important. In which port are you passing in what value? So this might hold. And this is more or less an experimental kind of a stuff where you might actually go ahead and put in some wrong connections and you might get in some errors. So you actually need to go ahead and troubleshoot some of those at times, not always. So we've actually gone ahead and we've almost built a model. Now we need one more table here, or one more data set, that is movie IMDb titles. Let's place it here. Okay, it has gone somewhere. Yeah, so I place it here. There you go. And whenever we have a new data set, we always visualize it to understand what it has. Okay, this should not take this long, but for some reason it is. So I have this data set where I have movie ID and movie name. So I would be using this data set for my recommender, where it has some IMDb titles, which is not the actual IMDb, that website which we have. It is a sample data set that is created. So we have this data set here. Now that we've seen the data, I'm gonna go ahead and use a command called as edit metadata, and I'm gonna place it here. And as usual, I'm gonna go ahead and put this thing in here. Now, if I come here, as you can see, there's this column here which says select certain columns which you want to use. So what are the columns that I want to pass to my metadata basically, or what is the metadata that I want to use? So I'm gonna go ahead and click on launch column selector. And in this case, with rules, I would start with no columns and I would say include. So what are the columns I need? First is I need item. So you have to hit the enter button. You won't be given a suggestion here. Okay, for some reason it is not taking in this value. Let me see what is wrong. Okay, we need to pass in first values to this so-called metadata. Before that, we won't be able to deal with items because we just took a look at this data set and it does not have item value. That is why we are not able to pass in that value. So let's pass in other values to it, the values that are more relevant to this data set. So we'd be coming here and we'd be selecting some other values. Now you can see that we have these values that are available. So let's just go ahead and select those. There you go. And I say okay. So the error is gone now. Now we have a metadata which is made available to us, and I have a model which is up and running here. Now I need to put in joins here. Now if you all know what joins do is, they basically help you select data from one table to the other. So we have two tables here, or two data sets. So I want to combine the data that these two tables have. Now I won't be getting into the details of joins and all those things, but we would be using them here for the general reference sake. So I have these two data sets here, and I want to predict or compare the table with the table that is here. So what I'm going to do is I'm gonna build a model or create a join that lets me compare the movie names from one dataset with the other, or give me recommendations from one of the two datasets, right? So for that, I would be needing a join here. So let's just come here and say join. Okay, before we get into this thing, there is one more important point. My edit metadata, data type, it has to be string. There you go. Now I need to pass in values to this tab as well. So for that, I would be needing a score from here. So I would be taking this and I would be placing it here. There you go. And one from the metadata to this joint. Now, what are the values that I want to pass in here? Now it should be item, I believe. So as I've said, hit the enter button. There you go. And you say okay. And columns from R or the other table, what do you want from here? I would be saying maybe movie ID. There you go. I say okay. What kind of join do I want? I want left outer join. Now again, I won't be getting into the details of these joins. Don't keep the right key columns because that is the reason I'm using this join. There you go. I would be needing one more join here and I would be pulling it here because the first join would just give me the movie ID, but I just don't want the ID. I want the movie name as well, right? So I'd come here, I'd pull in this thing and I would pass it to this data set and edit metadata. There you go. Again, if I come here, it would ask me for values. I would say, give me related items if you have any. And here, I want the movie name. We would say save. If you missed out on one thing, we need to come here first and remove this left outer join and now save. We are bound to have some errors, guys, so stay tuned. Now this thing runs, it would run it tab by tab or module by module, and then everything would be executed. So this might take a couple of minutes. Once the module or the tab is executed, it shows a green tick on it. As you can see here, we have ticks here and here. This might take a longer because we have increased the number of iterations to 20 in the slide or in the tab when we were working on it. So the whole processing might take a little longer than normal. Okay, it says related item not found. Let's see why is that happening. Launch recommender selector. Yeah, this is the one that is the related item one. Probably there is no related item variable in the dataset that we generated. Now, as I've told you in the first model, I'll show you where. First, let me select this for now and let me say, okay. Here in the score match box, I had passed in number of related items, right? It was one. So by default, it was given a name called as related items one. So that is something which we are passing in here or something that we would be displaying. So there you go. So what we've done is we've actually gone ahead and put in all the stuff that we wanted to. Let's just see whether it runs. And once it runs, I would be explaining this again to you people. So do not worry. First, let's run it. Now this time around it should happen quicker because most of the stuff is done. We just have the error in the last tab or the last module. So the other parts should be done quicker, as you can see. And now the last one would be implemented and it is done already. So guys, our model is up and running. Let's just go ahead and check. So when I click on this icon and I say visualize, it should give me some values. See how relevant values these are. Let's just verify it. Now this being a model, it might not be that accurate, but let's hope it gives some values. It is not giving me the movie name and movie ID for the other section or the related item. Let's see why is that the case. But it says if you have seen this movie, you might like this movie, but we do not have that movie. So let us see where we have gone wrong first. So there is some error here or here. We have a movie ID here. So let's just come here and see. Okay, so we can just match ID to ID or map ID to ID. So let's remove this for now and say movie ID and then see whether we get the output. So I say save, not save as. I would say save and I would run this. So again, it should run quicker than the last time. There you go. Now let's just see what is the output that we get. So I say visualize. And there you go, guys. It's as simple as this. I mean, we put in or pulled in some values and we've edited certain values and we have the result here. Now, this is an Indian movie called as Talash, and it says that if you like this, you might like this. Oblivion, probably Jack Reacher. I haven't seen either of this. Iron Man, you might like Stand By Me. So I don't think this recommender is that accurate, but probably I'm sure that there would be some movies in it which are more relatable. So, and for people who are big movie fans, they probably would be able to relate a lot more to the movies that are here. So, again, you can actually go ahead and select the number of related items that you want to select, and you might actually go ahead and tinker and tailor your algorithm a little more. For that, you have to play with the values that are there you have in this algorithm. You can just come here and switch in these details, and probably the answer might vary depending upon the inputs that you pass to this algorithm. So this was my basic aim. I wanted you to get some hands-on on Azure Machine Learning Studio and nothing more than that. But as far as this model goes, or this particular session goes, we've actually gone ahead and taken in two data sets. We've actually gone ahead and built a model, trained it, tested it, and then we've used a join to actually go ahead and see what would be the possible movie that you might want to watch if you liked one of those movies. So again, as I've already mentioned, it might not be that accurate. You are free to go ahead and play a little more with it. You can pass in your own data set